Hello, ladies and gentlemen. Welcome back. We are on chapter 6.3. We're going to perform function operations and composition. And we're also going to talk about the domain of a function. All right, let's get started, ladies and gentlemen. So we've got two functions here. We've got f of x, which equals 5x to the 1/3 power. We have g of x, which equals negative 11x to the 1/3 power, and then we're going to add those two functions together. But before we do that, ladies and gentlemen, let's talk about domain. Remember, domain is the x values. So we're going to use the calculator to kind of visualize this. All right, here we go. So I'm going to take my calculator and I'm going to type in 5x to the 1/3 power, which I already have there. All right, so we've got 5x to the 1/3 power. I'm going to go ahead and hit the graph button and look at the graph. Okay, it makes this kind of like cool little curve. It looks like there are no breaks in that graph at all. I'm also going to go ahead and take a look at the table. So I'm going to go to the table and I'm already down here at positive 21. And it looks like everything has a partner. I'm just going to scroll to the negatives for a little bit. Again, everything looks like it has a partner. Each x value has a partner, a y value, okay? Each input has an output. So it looks like all of those x values will work. Now, let me do this really quick, ladies and gentlemen. I'm going to use a capital R with a double vertical line, okay, to represent all real numbers. Now, you may, if you don't have me as a teacher, you may want to ask your teacher how they want you to symbolize all real numbers. Okay, this is how I like to have students symbolize all real numbers. So in this first one, the domain, I'm going to use brackets, is all real numbers. That means all of the x values, every single number works. Okay, all of the real numbers work. If I go ahead and look at the negative 11, okay, so if I type that in really quick. Now, folks, I'm going to try to make this video as short as I can, but if it starts to get too long, take a break. Pause, go do something else for a while, and come back to this video. Again, I'm going to make it as short as I can, all right? But if you need to take a break, pause, come back to it, and then finish it up later. All right, enough with that. Let's keep going here. So I'm going to go ahead and put in negative 11x to the 1/3 power. I'm going to go ahead and look at the graph. There it is. Okay, wow, that's a strange looking line. I'm going to go ahead and take a peek at the table. Again, I'm looking, do all of these numbers, do all of these x values have a partner? Okay, well, I'm not going to scroll any further into the negatives, but I'm going to go down and look at the positives. So far, everything looks like it's working. Okay, so I'm going to venture to say that, yeah, these are all real numbers also. Okay, now I'm going to take those two functions and I'm going to add them together. So I'm going to go ahead and take the 5x to the 1/3 and I'm going to add it to the negative 11x to the 1/3. Now I'm adding them. All right, so 5 plus negative 11, that's going to be negative 6x to the 1/3. Okay, the rational exponents have to match, folks. It's x to the 1/3, x to the 1/3. Okay, we can add those together because they match exactly. Now, do not apply the rules of exponents to this because there's a plus sign between those two functions. Okay? Now, the domain here, ladies and gentlemen, it's going to be exactly the same as the domains up above. If you want to go ahead, put that into your calculator and look at it, please feel free. But the domain is going to be all real numbers. All right, let's move on. Okay, now we're going to subtract the two. All right, so let me go ahead and write this out. So we're going to take 5x to the 1/3. we're going to subtract the negative 11x to the 1/3. All right, I'm going to switch, there's a sign change there. Turn that to a positive negative, or a positive positive, sorry about that, plus positive. And add those together, and that's going to be 16x to the 1/3. And if you want, you could type that into your calculator, but guess what? It's still going to be, the domain is still going to be all real numbers. Okay, let's take a look at this next one, ladies and gentlemen. All right, here we're going to multiply, and we have f of x equals 8. Okay, you should recognize that as a linear function. And we have g of x equals 2x to the 5/6 power. Well, first of all, 8x, okay, that should be obvious, folks. I'm just going to go ahead and put it in really quick because it doesn't take very long. I'm going to put 8x into my calculator. Okay, you should know that that's a linear line. And if it's linear, it goes on forever, right? So the domain, again, if you want, you can look at your table. The domain, all of the x values have a partner, so the domain is all real numbers. Now, the next one, however, this is why you need to check these. The next one is going to be a bit different. Let's take a look at it. So let's type in 2x raised to the 5/6 power. Now, just a reminder, if you've got an old calculator, you have to put that fraction in parentheses if you are using an older handheld calculator. All right, because otherwise it doesn't know that that's a fraction. All right, so now I'm going to look at the graph. Whoa, okay, it almost looks linear, doesn't it? But it's not. It's not linear. But it doesn't, it looks like it started right there at the origin, doesn't it? Okay, well, let's take a peek at the table. Whoa, look at that. We've got some error messages, ladies and gentlemen. That means those numbers don't work. -1 doesn't work. -2 doesn't work. -3, oh, you mean all of these negatives, they don't work. That's interesting. Okay, well, part of the reason is if you look at the rational exponent, folks, it's 5/6. The denominator is even. Okay, that causes that to happen. All right, so what is our domain? Well, our domain starts at 0 and gets larger. So now when I write this one out, ladies and gentlemen, I'm going to write this out like this. I'm going to go ahead and put my bracket, and I'm going to put x is greater than or equal to 0. So the domain starts at 0 and goes on forever. Okay? The domain is x is greater than or equal to 0. All right, well, let's go ahead and multiply these together really quick. So let me take the 8x times the 2x to the 5/6 power. Now, folks, we're multiplying. So we take the two bases and we multiply them. Okay, 8 times 2 is 16. X. Now, this is where we apply our exponent rules. Okay, it's a times sign between the bases, but we add the exponents together. Okay, and if you need help with adding exponents together, we have this wonderful piece of technology here. Okay, 1 plus the 5/6. Okay, now hit your math button. It's underneath the green button, and pick fraction because we want it to give us the answer back as a fraction. 1 plus 5/6, ladies and gentlemen, is 11/6. All right, so this becomes 11/6. Now, if I check that, ladies and gentlemen, so let me go ahead and type this in quick. I've got 16x to the 11/6 power. and I look at the graph, it looks like it's starting at the origin again. Okay, I'm going to go ahead and verify that with my table. So I need to go and see if the negatives work. Nope, the negatives don't work again. So that means my domain starts at 0 and gets larger. So I'm going to go ahead and I'm going to put my bracket, x is greater than or equal to 0. All right? So if in doubt, please use your calculator to verify. All right, let's keep going here. So let's go ahead and divide these two really quick, and then we're going to move to something else here. So we're going to take the 8x, and we're going to divide it by the 2x to the 5/6 power. All right, so we're dividing, ladies and gentlemen. So 8 divided by 2 is 4, right? 8 divided by 2 is 4. And now the exponent here is a 1. Now remember, what we do with exponents here, ladies and gentlemen, is we subtract. And if you take 1 minus the 5/6, okay, hopefully you don't need a calculator for that one. That's going to be 1/6. So this is going to be 4x to the 1/6 power. Now, I'm going to go ahead and just see what the calculator says here, ladies and gentlemen. I'm going to go ahead and put that in. I'm going to put in 4x to the 1/6 power, and I'm just going to take a peek at the graph. Well, look at that. It looks like it starts at the origin again. Okay, now things will evolve here, folks. Yes, yes, indeed, that is true. Look. Starts at 0. The negatives are error messages. So the domain here, ladies and gentlemen, is x is greater than or equal to 0. All right, let's get to composition of functions. So we have two functions here. We've got f of x equals 2x plus 1, and we have g of x equals x squared minus 5. So when we do composition of functions, we always look what's on the inside. The g of x is on the inside, folks. So what we're going to do is we're going to take our f of x, and we're going to replace the x part. We're going to plug the g of x into the f of x. We're going to plug the g of x into the f of x. So that means we're going to replace that x, ladies and gentlemen, with x squared minus 5. Again, I threw the x out the window, and I replaced it with the g of x, which is x squared minus 5. Okay, now I'm going to go ahead and simplify this. So I'm going to do the distributive property. Okay, so now I have 2x squared minus 10 plus 1. And then I can take the minus 10 plus 1, and I have 2x squared minus 9. So my new function, ladies and gentlemen, my composition of functions is 2x squared minus 9. Okay, now the next one, look, we're going to go the other direction. We're going to plug the f of x into the g. All right, so I'm going to put my parentheses squared minus 5. Okay, so the x I'm going to replace with 2x plus 1. All right. Well, if you recall, ladies and gentlemen, that means 2x plus 1 times 2x plus 1 minus 5. Okay, because there are two of them. So that means we have to FOIL. All right, so if I FOIL, first outside, inside, last, let's see, I get 4x squared. Okay, I'm going to go ahead and condense this right away. Let's see, 4x squared, 2x and 2x, that's going to be plus 4x and then the last term's plus 1. Okay, so when I FOIL, that's what I get, and then I still have a minus 5. Now, 1 plus the minus 5, my final result, ladies and gentlemen, is 4x squared plus 4x minus 4. So when I plug the f of x into the g of x, I get 4x squared plus 4x minus 4. Okay, let me just double check to make sure I didn't make any mistakes. 2x, 4x squared, 2x plus 1, and then I've got the minus 5. Yep, that looks correct. All right, now I do have two others right here. I'm not going to do them to save time, but what you would do here is you would plug the f of x back into itself. So I'm not going to solve it, but I'll show you what it looks like. So f of x, remember, is 2x plus 1. So if I plug it into itself, this is what it would look like. I throw the x out and I replace it with 2x plus 1. Okay, then I could solve it. Okay, but to save time, I'm not going to do that. Okay, the next one, if you remember, g of x equals x squared. Just make sure I do it right. X squared minus 5. So I would plug it into itself. So that means, ladies and gentlemen, I would throw the x out and put the g of x into itself and solve. Okay, but I'm already past 15 minutes, so we need to keep going here. I got a couple more things. All right, again, if you need to take a break, now would be a great time to take a break and come back. All right, so here, these are much easier, okay, because you're not just dealing with you're just dealing with numbers. You're plugging in numbers. All right, so here we go, ladies and gentlemen. So here's our two functions, and you can notice that it says f of g of 3. F of g of 3. So you're going to start by plugging the 3 into the g of x. So we're going to go g of 3 equals 2 times 3 plus 1. Okay, that's right here. And so I'm going to find that g of 3 equals 6 plus 1, which is 7. Now I take that 7 and I replace it. So I'm going to like imagine that I replaced the g of 3 with a 7, right? So now I'm going to take and replace that x in the function f with 7. So f of 7 equals 3 times 7, which is 21. That is your final answer, ladies and gentlemen. Always start on the inside. Okay, always start on the inside. All right, so this one says, okay, plug the 9 into the f of x. Okay, here we go. So I'm going to plug the 9, always start on the inside, into f of x. So f of 9 equals 3 times 9, and 3 times 9 is 27. Okay, now I'm going to take the 27, I'm going to like imagine that that becomes a 27. Now that's going to be g of 27. So g of 27 is going to equal, let me move this down a little bit more, 2, well, not quite that far, 2 times 27 plus 1. And so that looks like that's 54 plus 1, which is 55. And that's our answer.